Hi folks, we're going to take a look at page 39, number 3, and I'm going to choose the third function, which I have here. So part A asks us to determine the zeros and indicate the order. Okay, so let's start with that. So here the zeros are, since we've got it in factored form, we just have to look at each factor and determine when it's equal to 0. So x plus 4 can be equal to 0, so that means x is equal to negative 4. You know, I don't think at this point in grade 12 necessary to really show this step, so I won't show it for the next one. So x equals 1, x equals negative 2. You know, here if you want to actually solve it out, you can, just to make sure you don't make a mistake, but I'm happy for you to just put 3 over 2 right off the bat. Okay, so next thing is let's determine the order. So this just has to do with the exponent on each of the factors. So here the exponent on each of these two factors is 2. So this is, if we put an order row here, so this is order 2. X minus 1 also has an exponent 2, so this is also order 2. X plus 2 has an exponent 1, so order 1. And 2x minus 3 has an exponent of 1, so the order is 1. Okay, and we'll use that in a little bit to graph it. Okay, part B asks us to determine whether the function is even or odd. Okay, and since we want to determine it for all possible values, okay, we can't work with any specific values. So what we have to do is we have to figure out what h at minus x can be written as, and if it's exactly the same as h at x, then we know that the function is even, and if it's exactly the negative of h at x, then we know that it's going to be odd. Okay, so I'm going to say this nice and loud. Do not, absolutely not expand this thing. Okay, that'll just take you 15 minutes and chances are you'll make a sign error somewhere. So we definitely don't want to write it in standard form, even though that's the easiest way to calculate h at negative x. It's just not worth the time to expand something crazy like this. So what I'm going to do is I'm just going to input negative x directly into this equation. Okay, so what do we have here? So here instead of x, we're just going to replace that by negative x plus 4 squared, okay, negative x minus 1 squared, negative x plus 2, and here 2 times negative x minus 3. Okay, so in order to relate this expression to that one there, well, I see all these expressions have positive x's, okay, and here positive 2x. So I'm just going to do what I can to achieve the same form for these variables. Okay, and the way that I can do that is I can just factor out the negative 1. Okay, so here I'm going to factor out a negative 1, and what are we left with? We're left with x minus 4 squared. Here again, factor out a negative 1, so we're left with x plus 1, okay, squared. Here we'll factor out a negative 1, okay, and we've got x minus 2, and we factor out a negative 1 here, and we've got 2x plus 3. Okay, so right off the bat I see that these two negative 1s will multiply to 1, so those have no effect. Okay, and again, I want this expression to look as much like the original one so I can make a determination whether they're equal. So here, I've got this negative 1 multiplying the x minus 4, and the whole thing is being squared. So the negative 1 here squared will just become positive 1. So this can be written as negative x minus 4, which of course is going to be squared. Similarly here, I've got a negative 1 times x plus 1. When we square the negative 1, it just becomes positive. So here I'm just left with x plus 1 squared. And then here we're left with these factors x minus 2 and 2x plus 3. And here we could definitely make the determination that this expression is not equal to the right side of the original function, and it's not the negative of this expression either. Okay, so here we can say this is not equal to h at x, okay, and it's not equal to negative h at x. Okay, hence we can say h is neither even nor odd. Okay, so no symmetry. Okay, so here again, you definitely don't want to ever have to expand something like this, so just follow the process, but we had to do a little bit of work to more clearly compare the two functions h at x and h at minus x. Okay, so let's go to C, and let's see, I think C asks us to sketch a graph of the function. Okay, now we're going to keep in mind that when we sketch these graphs, there's not going to be much we can say about the maxima and minima unless they occur at the x-axis. Okay, so the first thing we have to do is we have to determine the degree of h. Okay, and let's figure it out here. Well, we realize that if I were to square this expression here, I'm going to get an x squared as my leading term. If I square this here, I'm going to get another x squared, and then here I've got an x, and here I've got a 2x. So if I were to multiply just the leading terms of all these factors, which is going to give me the leading term of the whole thing, well, I'm just going to have x squared times x squared, so x to the 4th, times x is x to the 5th, times 2x is going to be 2x to the 6th. So the degree is going to be 6, and the sine of the leading coefficient, so I'll call it a6 since it's a 6th degree polynomial, and we realize here that when we multiply all the leading terms we would end up with 2x to the 6th, but because we have this negative sign in front, we realize that our leading coefficient is going to be less than 0. Okay, so that means that the end behavior of this function is going to be that it goes to negative infinity on both sides. Okay, so let's graph this here, and again I'm going to do something very simple. Okay, so here let's input our x-intercept, so we have an x-intercept at -4. Okay, where's our next x-intercept? We have an x-intercept at -2, sorry. So here there's 2 and there's 4. So where's our next x-intercept? Our next x-intercept will be at 1. Okay, and our next x-intercept after that will be 1.5, 3/2. So there's our 4 x-intercepts. Okay, now remember, because the leading coefficient is negative, we're going to start off at negative infinity and start going up. So at -4, we see that our 0 is of order 2. So I know that it's going to come up and it's going to look like a parabola near that 0. Okay, so let's draw that. Then at -2, the order is 1. So I know that it's just going to go straight through. Let's see what's happening at 1. At 1 we have again a parabola of order 2. Okay, so make sure it looks like, a 0 of order 2. And then at 1.5 we have a 0 of order 1. So we know it's going to go straight through. And of course my end behavior needs to be going to negative infinity. Okay, so there you have it. So to recap, this was already in factored form, so reading off the zeros was easy, and determining the order is just about looking at the exponent of each of the factors. Okay. For determining even or odd, I still take -x and I input it into the equation, but I input it as is, and I just had to do a bit of work to factor out these negatives so that I could more easily compare h at -x to h at x and make the determination here that it was neither even nor odd. And lastly, to graph the function, just knowing the zeros is not enough, knowing the order of the zeros is not enough, we also needed to determine the degree and the sign of the leading coefficient in order to get the end behavior. But then once we had the end behavior, we had the degree, the order of the zeros, we were able to sketch a graph. And at this point here, we won't worry too much about the y-axis, okay, because we're not able to determine exactly what these maximum and minimum are. Okay, that's it for this one.